This is the third video on organic reactions. I'll be discussing addition reactions. So we have 4 types of addition reactions. The first one is hydrogenation, the second one halogenation, hydration, hydrohalogenation. So again, what I like about these names is that they explain what will be your reactant. So we're gonna start with the first one, which is hydrogenation. Okay, firstly I need to discuss what are the conditions. Okay, so the condition for addition reactions is that they only take place in unsaturated compounds. So you need to know that. That's why it's highlighted red. So if you're taking notes, you must highlight it red so you don't forget, you keep remembering when you revise. So unsaturated compounds simply means the hydrocarbons or the bonds between the between the carbon and carbon are double bonds or triple bonds, unlike the saturated carbons where it's only single bonds. Okay, so let's start with the first one, hydrogenation. So this one, hydrogenation, it talks about hydrogen, so it's the addition of hydrogen, okay, across carbon double or triple bonds. All right, so you'll be adding hydrogens on the carbon and carbon double bonds or triple bonds. So your reactants, it's your alkenes or an alkyne, but your product is gonna result in an alkane or a haloalkane. You start with double bonds, you end with single bonds. Okay, so let's do the first one, hydrogenation. So you need to know all these types of reactions, and you also need to know the conditions. So the condition for hydrogenation is that we need a catalyst. You know, the function of a catalyst is to speed up the rate of reaction. So the catalyst that needed here is platinum, palladium, and nickel. You need to know that, so write it down right away. So you need to know the catalyst, the names of the catalysts which are needed. So sometimes they can just give you a molecule, and so let's say this molecule A, and they just show you, okay, there's a catalyst PT, PD, or nickel. Then they say give the name of compound B. Let's say here you start with ethene, or they can say name the kind of reaction. So the moment you see those catalysts, then you know it's hydrogenation. It means you must add hydrogens on the double bonds, and then you will know your product will be an ethane. Okay, that is something we're going to practice later. So hydrogenation, we start with an alkene. So let's say I'm using an ethene. Okay, let's use a propene. So propene, it's 3 carbons, double bond. So it means here I will have 2 hydrogens, 1 hydrogen, 3 hydrogen. So be careful when you're drawing your structures. Make sure the carbons are only surrounded by 4 bonds. Okay. Then hydrogenation means I'm going to add hydrogens. Again, a hydrogen is a diatomic element, so it must exist as H2. Okay, so that's why it must always be like that. So for the sake of showing the bonds, I'm going to show a hydrogen bonded to another hydrogen. So what they're saying here, these are very simple because you're just adding the hydrogens. So you already know if you're drawing your structures and you don't have enough hydrogens, it means there's a double bond or a triple bond. So if you have enough hydrogens, then you already know you only have single bonds. That is what is going to happen here. This propene doesn't have enough hydrogens. That's why they exist a double bond. So what is going to happen, we're going to add these hydrogens on these carbons with the double bonds. Then the double bond will be broken into single bonds. Okay, so your product is going to be 3 carbons. So in the first carbon, instead of 2 hydrogens, now we now have 3 hydrogens. And then in the second one, instead of 1 hydrogen, we have an extra, so that is 1. Can you see now why the bond is broken into single bonds, because if I put a double bond here, it now doesn't make sense. The carbon will be now surrounded by 5 bonds, which is wrong. So that is how we break up the bonds, by addition. And then the last one stays as it is. So that will be your product. Okay, I can give another example. Let's say I'm using a pentene 5, let's say 2 pentene, or I must write pent 2 in. So I have 5 carbons at double bond at carbon number 2. Then first one I have 3 hydrogens, the second one 1 hydrogen, the third one 1 hydrogen, 2 hydrogens, then 3 hydrogens. I add H2, so okay, let me write it as hydrogen bonded to another hydrogen. What is going to happen on the double bonds? Okay, the hydrogen will be added on that carbon, and you only add on the carbons which are forming the double bond. Okay, so your product, the first carbon has 3, the second one it had 1, but now it has another hydrogen to make them 2, same as the third one. So that is exactly what's happening. You start with the pentene, you end up with a pentane, from alkene to alkane. This is very nice and simple. So let's go to halogenation. In halogenation, it's basically the same thing you were doing in hydrogenation, but now you are only adding halogens, which means you start with alkenes and then you end up with a haloalkane. Okay, so let's see. So now the second one is halogenation. Okay, halogenation. So halogen tells you will be adding a halogen. So halogenation for addition of a halogen, which is very nice. So the first example I'm going to use, I like propane, so I'm gonna use propane. Or I can use a butane. Okay, let's use a but 2 in 4 carbons. At number 2 I have double bond. The first one has 3 hydrogens, the second one has 1 hydrogen, third one 1 hydrogen, 1, 2, 3. So the halogen that I'm going to use is a bromine. So it's a Br bonded to another Br. Okay, again this is a diatomic element. So what's gonna happen? The first bromine will be added to carbon number 2 with a double bond. The second one will be added to carbon number 3 with a double bond. So it will be broken down into single bonds now. So let's see your product. The first carbon, 3 hydrogens. Second one, 1 hydrogen, and a bromine, and then bonded to the third carbon. Do you see now why the double bond is broken? Okay, and then the third one again 1 hydrogen, and then a Br, and then the last one has 1, 2, 3 hydrogens. That is for halogenation. Okay, then let's go to the third one, hydration. So for the hydration, there's something interesting about it. I'm going to show it here. So this one is addition of water to form an alcohol. So now our product is gonna be an alcohol. Don't forget alcohol is a OH, okay, which means in one of them we're gonna put an OH and in the other one we're gonna put a hydrogen. So let's see the first example using propene. So 3 carbons, that is the propane. And then we add H. Every time when you add water into something, it's gonna form an alcohol. That's why I always write it as H bonded to OH, okay. So let's see what can happen here. 2 products can form. You can see now in hydration we are now substituting two, we are now adding 2 different things, which is hydration and which is a hydrogen and an OH, which means 2 possible products can form. Okay, so I'm going to show you how they can form. In the first case, the hydrogen can come and attach in this carbon, and the OH can attach in the first carbon to form CH, H, and then I put an OH, and then you have a C, H, and then the hydrogen that is added, and then C, 1, 2, 3 hydrogens. That is the first case, but this can go the other way around. Instead of what we did now, this hydrogen can now decide to attach in the first one, and the OH can attach in the second one, okay, to form what? So if that happens, we have H, and then in the first one we added the hydrogen, and then in the second one we added an OH, and then the rest stays as it is. So you now have a job to determine which major product is going to form. So for this, to determine the major product, we're going to use the Markov-Nikov rule, which is written in the first, on this page here, the Markov-Nikov rule. So this rule basically states that if you have to add a hydrogen and something else, the hydrogen will always prefer to go where there is most number of hydrogens. That is the rule. So let's check. In the first carbon we have 2 hydrogens, 1, 2. In the second carbon we have 1 hydrogen. So the hydrogen will go to the first, it will prefer to go to the first carbon, which has the most number of hydrogen. So our major product which is going to form will be this one. So this one is wrong. So you must always be careful when it comes to hydration. Always remember to use the Markov-Nikov rule, okay? And also don't confuse hydration with hydrolysis. Hydrolysis is substitution and hydration is addition. So in addition, this is how you can remember. In addition, you are adding everything. If you are adding 2 bromines, you must add both of them, okay? If you are adding water, you must add the OH and the H. But in hydrolysis, you're only substituting one of them, and the other will be a byproduct. Okay, so don't confuse the two. Let's go to the last one, hydrohalogenation. So hydrohalogenation, again, it tells you are adding a halogen and a hydrogen. So let's look at an example. So number 4, hydro for hydrogen. So hydrohalogenation, so that is addition of hydrogen and a halogen. So you start with double bonds. I'm gonna use a propene again. So propene, I have 3. And again, addition reactions occur in unsaturated compounds. That is how you can also differentiate it from substituting. So you start with propane, then we have double bonds, H, 1, 2, 3 hydrogens. We are adding a hydrogen and a halogen. So I'm going to use HCl, a chlorine and a hydrogen, HCl. So what can happen here? Again, the first case, the hydrogen can attach to this one and the chlorine can attach to that one. The second case, the hydrogen can attach to this one, the chlorine can attach to this one. So according to Markov-Nikov rule, we're going to go with the blue because the hydrogen must go where there is most number of hydrogens. Okay, so it means the product which will form will be C, and then we add the hydrogen, and then the rest of the hydrogens as they are. In the second one, we add the chlorine, and then the hydrogen as it was, and then hydrogen, and hydrogen. Okay, so that's the end of addition reactions. What you need to check again is if you have any reaction conditions. Let me see if I missed something. So I missed the reaction conditions on the hydration. You must make sure you note them down. You will be asked about these conditions. So in hydration, you need a concentrated sulfuric acid. Okay, it's important for you to know that. Let me see what else I missed. Okay, that's all.